So let's start our meeting today to continue what is the meaning of influence line. Last meeting, we started to learn what is the main concept of influence line. And we learned that influence line is a diagram drawn due to the effect of moving load. Moving load does not mean a person is moving on a apartment or on a floor of apartment. No, you are nothing. I'm talking about moving load related to trucks. You have very heavy trucks moving on a bridge. So we need to figure out what is the effect of this moving load, for example, on this reaction, for example. And we decided, because we have many different type of trucks, which one I'm gonna use. Okay, we can model all of them to be unit load. Unit means the value is 1 and 1 concentrated load, unit load. And we started to learn based on Molar principle, how can I draw the influence line for reaction? We learned 3 steps: move, keep, the resulting deflected shape. Move the support. You are looking to draw the influence line for reaction, for its reaction. Keep any other support without movement. The new shape will be the new deflected shape will be the influence line for this reaction. Please go ahead. Everybody right now, please go ahead and you have your pen. Go ahead and catch this pen from this end with your hand. Go ahead and catch your pen by your hand from this end. So your pen right now with your hand looks like a beam fixed from one side. That's right. That's right. If you move your hand up by 1, I believe, because this pen is only supported with your hand, I believe this pen will move like this. Do you agree? Do you agree? Any question related to this point? Guys, please catch your pen with your hand from one end. So the rest of the pen is free. So this one represents a cantilever beam supported by fixed support from one side. If you move your hand up, the whole pen will move up. Any comment? Did you try it? Did you try it? Okay. So that means for this fixed, we have vertical reaction. For example, this support is A, so we have YA. Move, keep the new deflected shape. I'm sorry? Yeah. Move the support by unit displacement, 1. So this fixed became here. What do you expect about the rest of the beam? Because this beam is only supported by this fixed, if you move this fixed, the beam will move with the same value. So the new deformed shape will be influence line for reaction YA. So if you have fixed like this, we have vertical reaction YA, and you would like to draw influence line for YA, let's do it. Move the support up by 1. keep any other support. I'm sorry, we don't have any other support to keep it. So if you move this fixed up, I believe the whole beam will move up with the same value. So this new shape can be represented on flux line for reaction YA. Guys, please pay attention. What is the difference between this situation and this situation? If you have your pen also supported here and supported there, if you push this support up by 1, I have to keep the other support as it is. So the new position of your pen looks like this. But in the case of fixed, I'm so sorry, your pen has only one fixed support on this side. So if you push this support up by 1, and you have to keep any other support. Do you have any other support? Do you have any other support to keep it? No, we don't have. So the whole beam will move up by 1. So the new shape will be on flux line for reaction YE. But this one is on flux line for reaction YE. Huge difference between this one and this one, because this beam is supported by 2 supports. I have to move one up and I have to keep the other one. But this beam is supported by only one support. If you move it up, the whole beam will move up. Is it clear? Is it clear? If you have any question, let me know. If you have any question, let me know. Okay. Because the fixed has a vertical reaction and the moment, hey guys, last meeting we decided we don't care about any horizontal reaction. Do you remember my question? We don't care about any horizontal reaction for on flux line because your truck is moving and the weight of the truck all the time is vertically downward. So our concern is a vertical reaction, and because we have fixed, we have moment. If you would like to draw on flux line for moment, this moment, which is assumed to make this beam or this cantilever to smile, will rotate this fixed in the same direction, which is counterclockwise. If you rotate this fixed like this by angle theta equal 1, the new shape of this beam will be like this. So we will have a triangle with negative sign. This called on flux line for M at A. One more time. One more time. To draw on flux line for moment at fixed support. Just rotate this fixed support by angle theta equal 1. Clockwise or anti-clockwise, which direction? Based on the direction of moment. Let's do it. Let's do it one more time. We have fixed here. This fixed is supporting this beam. So I have moment. Which direction I'm gonna assume this moment? I'm gonna assume this moment to make this beam to smile. So I will assume it like this, MA. Can you rotate this fixed by angle theta equal 1? Which direction? in the same direction like this moment. So I'm gonna rotate this fixed like this. And this angle, theta equal 1. Remember, if you rotate this fixed, the beam must be perpendicular to the fixed. So your beam will be like this, to be perpendicular, to keep it perpendicular on the fixed. So the new shape of the beam will be like this, negative. If you would like to draw it in a beam, we have fixed like this. So influence line for MA, here is MA. Rotate this fixed by angle theta in the same direction of the moment. In this direction, theta equal 1. So the new shape of the beam will be like this. So this diagram, which is negative, will be influence line for MA. What will happen if the fixed on the other side? Nothing will happen. The same sequence. First of all, the direction of the moment will be like this, to make this beam to smile. I will rotate this fixed in the same direction like this beam, like this moment, I'm sorry. So I will rotate my fixed like this, angle theta equal 1. The new position of the beam is still perpendicular to the fixed. So the new diagram will be like this. This diagram can be called influence line for MA. So if you go back to this one, we have here moment at this fixed MA. I assumed it to make this beam to smile. If you would like to draw influence line for MA, please rotate this fixed by angle theta equal 1. In which direction? Clockwise or anti-clockwise? I'm not sure, but please rotate it in the same direction of MA. So I will rotate it clockwise. Theta equal 1. The new shape of this beam will be like this, because this beam must be perpendicular to this fixed. The new shape is negative because it's down. So the new shape can be called influence line for MA. If you have any question, let me know. So guys, if you go back, we learned how to draw or how to sketch influence line for reaction if you have a beam between two supports only. And we learned how to draw influence line for reaction for a beam between two supports, and we have extra part. And we learned to draw influence line for a beam supported only by fixed. If you have any question, let me know before starting to solve this example. If you have any question, please let me know. Okay. I started this example last meeting, so I will start it from scratch. We are looking to draw influence line for reactions. Okay, let's start. We have support A and we have support B. At A, we have vertical reaction, YA. At B, we have vertical reaction, YB. If you would like to draw influence line for reaction YA, do you remember? 3 steps. Move, keep the resulting deflected shape. Move support A up by 1 to the new location of this beam is up by 1. Any other support? Do you have any other support? Yes, we have. We have this one. Please keep it without movement. The new shape of this stick will be like this. Probably last meeting I labeled this support is B, and this one is A. It doesn't matter, whatever. If you would like to figure out what is the value here, go ahead and do triangle similarity. You will find this one will be 1.33. If you would like to draw influence line for reaction YB, keep the resulting deflected shape. Move this support B up by 1. Any other support, keep it. The new shape of this stick looks like this. With triangle similarity, I can figure out the value here will be negative 0.33. This one will be positive. Any question? I think everything is clear for this step. The next step, we need to figure out what is the influence line for shear and what is the influence line for moment at a specific point called C. Just to let you know, this bridge is starting from D to B. So any truck, if you have any truck, in our case, your truck represents one concentrated load. How much is 1? This truck is moving from point D to point B, the start of the bridge to the end of the bridge. That's right? That's right. Point C that you are looking for divided this trip to 2 parts. Can you see here? So this cut will divide your trip to 2 parts. The first trip starting from D to C. The second trip will continue from C to B. Just to be clear with you, before anything, the moving load will start from this end to this end. But we have a point C. Why you are looking for C? Because I'm not looking for C. The problem is looking for C. So point C divided this trip to 2 parts. The first part between D and C. The second trip between C and B. So first trip, the car is moving here between D and C. We don't like the part of the bridge where you have moving load. So I'm gonna use the other part. The other part looks like this. I did cut here. We have vertical reaction here, YB. At your cut, we have shear. Would like to rotate this part of the beam clockwise. And we have moment, would like to make this part of the beam to smile. So we have MC, we have shear at C. Go ahead and apply summation F of Y equals 0. We have positive V at C. We have positive YB equals 0. So V at C equal negative YB. If you take moment at C equals 0 and you assume this direction is positive, if you take moment at C, VC will be cancelled because we don't have distance. We still have MC and we have, remember this distance is 4 feet. We have negative YB times 4 equals 0. So MC in one side equal 4 YB. the second trip. The second trip. Right now, the moving load is here. Moving from C to B. So I don't like this part of the beam where the moving load is moving. So I will use the other part of the beam without moving load. What do you have on the other part? We have this part. We did cut here at C. We have vertical reaction here, YA. This distance is 4, and this distance is 4. At your cut, we have shear, would like to rotate this part of the beam clockwise. So I will assume it like this, VC. We have moment, would like to make this part of the beam to smile. So we have MC. Go ahead and apply summation. F of y equals 0. So we have YA. We have negative VC equals 0. So VC in one side equal YA. Go ahead and take moment at C equals 0. Assume this direction is positive. If you take moment at C, VC will be cancelled. We still have MC, and we have negative 4 YA equals 0. So the final conclusion, MC equal 4 YA. Do you have any question? Do you have any question about these calculations? I started as a story. If you have a kid and you would like to tell him or hear a story, I told you a story. The moving load is starting from D, this end, to B, the other end. But we have a point C. This point C cut the whole trip between two parts. The first strip will start from D to C. The second trip will start from C to B. So we have two trips, trip number 1 and trip number 2. If the moving load is moving on the first part of the bridge, we don't like this part. I hate this part because I already hating the moving load. So I decided to use the other part of the bridge. So I used the other part. When the moving load is moving on the other part, which is C to B, I started to hate this part because I already hate the moving load. So I decided to use the first part of the bridge. I already used it. I applied summation F of Y, summation moment, to figure out what is the value of shear, what is the value of moment. Just to remind you, my conclusion or my target, I would like to draw influence line for shear at C, influence line for moment at C. If you have any question, let me know. Okay, guys, let's start to play another game. I believe you did it when you are in elementary school. From D to C. From D, based on your calculation, from D to C. From D to C. We are looking for YB. We are looking for YB. Where is YB from D to C? Where is YB? Here is YB. From D to C. From D to C, I think you are talking about this little diagram. From D to C. Can you multiply this YB by negative. If you multiply this diagram YB by negative, I think it will be switched like this. This one was positive, it will be negative. This one was negative, it will be positive. Do you agree? From D to C, I'm looking for YB, but negative. From D to C, here is YB. Can you multiply this diagram by negative? So this one is negative, it will be positive. This one is positive, will be negative. One more time. From C to B. From C to B. We are looking for YA. Here is YA. From C to B, you are talking about this little triangle. Can you use this triangle without any multiplication? Because we don't have negative, we have positive, YA. Can you take it as it is? If you take this triangle as it is from C to B and put it here from C to B, so we have this triangle as it is, which is positive. You will find yourself, you draw a diagram, looks like this, which you called influence line for shear at C. One more time. One more time. It's for fun. Believe me, it's easy. By the way, this value based on the diagram will be 0.5. This value will be 0.5 from triangle similarity. Anyway, based on your calculations, please go ahead. From D to C, we are looking for YB time negative. From D to C, here is YB. Can you multiply this diagram, which is from D to C only, from D to C only? Can you multiply this diagram by negative? If you multiply it by negative, it will be switched like this. The positive will be negative, the negative will be positive. This value 0.5, this value 0.33. From C to B, we are looking for YA without any multiplication. From C to B, here is YA. Can you use this triangle as it is? Yes, I can. This value is 0.5. So the new diagram, which looks like this and this and this, is called influence line for shear at C. Can we try to draw influence line for MC? Yes, we can. Let's do the same game. From D to C, we are looking for YB multiplied by 4. Where is YB between D and C? D and C, wow, the same diagram. Can you multiply this diagram by 4? Yes, I can. By 4 positive. I don't change any sign. So this diagram will be the same shape, but this value 0.33 will be multiplied by 4. It will be 1.33. This value is 0.5 times 4, it will be 2. The negative will be negative, the positive will be positive. From C to B, please go ahead and use YB. From C to B, your YB is this little triangle. Can you multiply this little triangle by 4? Yes, I can. 0 here by 4 will be 0. 0.5 here times 4 will be 2. So you will have this triangle. So the new shape, which looks like this, will be called influence line for MC. So guys, for any problem in influence line, we have two parts. Influence line for reaction, you can do it without calculation. Influence line for shear and the moment at any specific point, you need to do calculations first. Based on your calculations, I will construct this diagram for shear and this diagram for moment. Do you have any question? Please go ahead and think about it. Do you have any question? Okay, I would like to play with you another game. Probably we need to go to the park to play this game. Let me remind you for something. Did you play with the balance swing? Balance swing looks like this. We have here something like this, and you are sitting on this side, and you have your friend is sitting on the other side. That's right. Did you play this game before? Did you? Sure. Everybody. I have a big accident for this game before. Anyway, so what will happen if this one is heavy? I think this one will go down. Do you think this one will remain as it is or will move up? Because this part must remain straight. So I believe the new position of this balance swing will be like this. That's right. You agree with this. Doesn't make any sense for any reason you found this person is down and this person is still down. That means no, we have something wrong happen. We have broken swing. We will never see this position. That's right. If you have any comment, please let me know. Okay. So please pay attention. If you have this balance swing is horizontal and is connected to another balance by hinge or pin. I have a question. What will happen if this side moved up? I believe this point will not move. I believe this point will not move. Anybody can tell me what's going on? What will happen for the two swings? What do you think? If I would like to move this side or this end of the swing, of the black swing, to be moved up, I believe 100% that this swing will be like this. I'm sorry, but the other swing is connected by this one at this hinge. So what do you think about the second balance swing? What do you think about it? I think the second one will be like this. Do you agree? Do you agree? Does that make sense? Remember, if you have connection between one stick and another stick or another piece here by hinge, we can expect that this one looks like this and this one can be like this. Does that make sense? This is the main purpose of using pin connection. This part must remain straight. This part must remain straight. This connection means this end is connected to this end. So if this end moved up, this end must move up. If this end moved down, this end must move down. Do you agree? Thank you. So that's clear? Okay. Let's start to think about this compound beam. Compound beam, what you mean? We have many supports. We have support at E. We have support at this one. Let's say this one is AB, so C and D, E, or okay, E. So we have many supports. Just to remind you, for this example, we have only two supports. For this sketch, we have this case two supports only. Or this case, we have only one support, fix it. But in this example, we have many supports, more than two. So we have three. This one is hinge, we have vertical reaction YA. This one is roller, we have vertical reaction YC. This one is roller, we have vertical reaction YE. We don't care about any horizontal reaction. We don't care. So go ahead and start to help me. If I would like to draw influence line for YA, influence line for YC, influence line for YE. We have a technique. Move, keep, resulting deflected shape will be the influence line. Move what? The support at the reaction you are looking for. Keep what? Any other support. The new deflected shape will be the influence line. Let's start. To draw influence line for YA, I will move support A up by 1. And I will keep any other support without movement. So this one will not be moved. This one will not be moved. Can you tell me what is the new shape? I believe if this point didn't move and this point didn't move, I believe this part of the beam will not move. If this side of the beam didn't move, the other side of the connected beam will not move because we have here pin connection. So I believe the new deflected shape will be like this. This diagram can be called influence line for YA. You are lucky. You are lucky. If you have a piece of wood or stick. This point did not move. This point did not move. That means the whole member will not move. If this point did not move, the connected part at this point will not move. But we moved this side up by 1, so the new shape looks like this. One more time. We would like to draw influence line for YC. Move, keep, deflected shape. Move what? This time we will move what? Move support C. So this support C, I will move it up by 1. Keep any other support. All other support, keep them. So this one will not move. This one will not move. So can you look to this part of the beam between point E and the C? You kept this point without movement. You moved this point C up by 1. So I believe the new shape of this part of the beam like this. That makes sense? So this side of the connection at B moved up by 1, or moved up. I believe the connected part on the other side must follow, will move up also. So the new position of this part looks like this. This is called influence line for reaction YC. Influence line for YE. Move, keep, deflected shape. Move what? I will move support E up by 1. Keep all other supports without movement. I will keep this one. I will keep this one. Guys, for this part of the beam, this part is 1 unit. This part is 1 unit, 1 piece. If you move the E up and you kept point C, so the new deformed shape looks like this. Do you agree? Because this side of the connection moved down, the other side of the connection must follow. So the new shape will be like this: positive, negative. This one is positive, this one is positive. This can be called influence line for YE. Do you like this beam? So our beam started to be more complicated a little bit. But if you would like to draw influence line for reaction, you have to keep in your mind, if you have 1 piece of beam and you decided this point to move up and this point will remain as it is, the new shape of this piece must be straight, 1 unit. 1 unit. If this piece is connected here by another piece at this pin connection, what will happen for the connection? This side of the connection moved down. The other side must follow. So the new shape of this side will be like this, like we did for this swing. Let's do another example. Let's do another example. But if you have any question, let me know. Okay, for this example, we have fixed support. We have two reactions. For on-flange line, we concern about only two reactions, MA, YA. We have roller at C, so we have one reaction YC. Just to keep in your mind, this beam consists of one part, two parts. First part is fixed at this side. The other part has roller support here. Between the two parts, this point and this point, we have pin connection. Pin connection means the two sides must follow each other. These two sides of connection must follow each other. That makes sense? Let's start. We would like to draw on-flange line for reaction YA, on-flange line for reaction MA, on-flange line for reaction YC. What will happen if to draw on-flange line for MA, I will move it up by 1. Any other support will remain as it is. But we have here a special case, because this part, which is fixed on this side, if you moved the fixed by 1, I believe we learned this today at the beginning of our meeting. The whole part which is connected to this fixed will move up. So I believe this part will move up by 1. Because this side of the connection moved up, the other side must move up. Because this point will remain without movement, the new shape of this part of the beam will be like this. Negative, positive. To draw on-flange line for MA, because this fixed and this part is connected to this fixed, I assumed moment to make this part to smile. Do you remember how can I draw on-flange line for moment at fixed? Yes, I remember. Rotate, fixed, support by theta equal 1 in the same direction for MA. So I will rotate this fixed by theta equal 1. The new shape of this part will be like this. So I think the new shape will be like this. Why? Because I rotated this fixed by theta equal 1. Any other support will remain without movement or rotation. Because this side of the connection moved down, the other side of the connection must move down. So the new position of this part of the beam looks like this. Positive, negative. On-flange line for YC. move support C up by 1. Any other support without movement. Guys, believe me, if you have fixed support and you have this part is attached to this fixed, if you did not move the fixed support, this beam will not change, because this part of the beam is supported by this fixed only. If this fixed did not move, this part of the beam will not move. So this part will not move, will remain as it is. So this side did not move, this side will not move, this point moved up, the new shape of this beam or this part will look like this. One more time. This part of the beam didn't move because the fixed did not move. So I draw influence line for reaction YA, influence line for reaction MA, influence line for reaction YC. So today we learned few things. The first one, if you have fixed support, how can I draw influence line for vertical reaction, influence line for moment at this fixed? If we are looking for influence line for shear and the moment at a specific point, we are going to use these calculations technique to draw this diagram and this diagram. If you have compound beam, what you mean by compound beam? We have parts of the beam connected to each other by pin connection. What will happen? Keep in your mind, this pin connection will keep each side to follow the other side. And we solved two examples to figure out how can I sketch the influence line for reactions. That's enough for today. Please, if you have any question, let me know before leaving. Don't wait until the end of this topic. Please study it one by one. Be up to date, because this part of the course is not easy. Not easy for you as a student, but not easy for any engineer. I believe if you ask any structure engineer about influence line, he will say something not good about it. So please keep in your mind to study it step by step, to do your homework. We have a quiz next week on influence line. So please study it step by step. Moment at fixed will never be positive. All the time will be negative. So let's start. We have two cases. You're fixed on the left side of the beam, or fixed will be on the right side of the beam. If you would like to assume this moment to make this beam to smile, if you would like to assume this moment to make this beam to smile, so no way. If you rotate this fixed following this moment, it will be like this. So this beam will be like this, which is negative. If you rotate this fixed to follow the assumed moment, so it will be like this. So the new shape of the beam will be like this, which is negative. So no way to be positive. Probably in other part of the beam will be positive, but for this part, which is supported by this fixed all the time, probably 100% will be negative.